Hello everybody, I'll get started shortly. If you're curious got a bit of feedback on the audio. Oh, that's better now. Sorry about that. Okay, so we're going to be getting started shortly. If you're curious as to what data set I'm going to be looking at, I suggest you have a look at the link. I've posted it in the chat, but it's also this one here. Oh, I didn't mean to move that. Got to learn to avoid the buff. Right, okay. The OBS thing. Right, okay. So this link here, for those of you who've missed it in the chat, that's the data set I'm going to be looking at. I'll give a quick introduction to that in a moment. It will probably be really useful as well if you have a look at the Graph Data Science library documentation, because I'm quite keen to have a play with some of the functions we've got in there, so it might be helpful to have that link up and running. So I'm going to be going through this. Really keen to get some ideas as to what you think as well would be good approaches for this. So by all means, ping them in the chat on Twitch if you're just viewing and you want to find another way of getting in contact with me. I'll keep an eye on Twitter as well. If you want to ping me on Twitter with any questions, we'll try and keep an eye on those as well. So hopefully we have many modes of communication to talk about here. Okay, so let's get going. Right. So what's the plan today? So basically, I'm really keen to go through this data set. So effectively, this is the BBC Good Food data set. My colleague Mark Needham and I have done some investigation of that data set, and the most recent, and I use the word recent sparingly because I just realised this was in June of last year, but I put together a blog post talking about how would I go about going through this data set and detecting duplicates, and I had a bit of a discussion in there about what's a duplicate, oh excuse me, that pollen's getting to me, just got to close the window. Oh my goodness. There is no escape from hay fever. Oh, excuse me. So, we were talking about how do we deal with duplicates, and there's this discussion about what's a duplicate, what's dealing with duplicates, what's dealing with entity resolution, and so we'll go through those posts. Anyway, what I'm quite keen to do is I'm very keen to go through and oh, excuse me. I'm very keen to go through and do a follow-up to this post, which is on dealing with entities. And so I'm going to be trying some stuff today. I've got some ideas I've worked on previously. I've got some things I would like to try out today. And absolutely, I'm really keen to hear about any things that you may be suggesting as well, or something that you've dealt with when you've gone through dealing with entity resolution. So we're very much going to look through some things I've done, and then we're going to have a look at some of the graph data science algorithms. So things like weakly connected components, I'm quite keen to have a go at to see if it does something useful. So again, really keen to hear your thoughts on this as well. So this is the blog post in question. For those of you who want to go away and have a play with this yourself with the data set, what you can do is if you go to part 1, so part 1 is all about what data model we sort of decided to choose on in the end, decided to go with in the end. We talk about the data set. You can get a copy of the data set and get that into the database. So you've got all the bits and pieces there to be able to get that data into the database if this is something you want to go and have a play with. And in this particular blog post, I was really keen to start thinking about how to deal with duplicate ingredients. So just as an example, if you put something in like almond, you get in this original data, you get things like almond and almonds, ground almond, ground almonds, almond flakes, flaked almonds, flaked almond. You get the idea. So you've got a lot of things there that you would argue is duplicate data. And again, this is going to be driven by whatever business rules you put in place. And this example here, I'd argue that if you've got the same word but one ends in a plural, so it ends in S or IES, so like cherry, cherries, and so forth, then I would argue, you know what, that's duplicate data. I want to think about dealing with that. And this blog post is all about some approaches that I thought about and used for dealing with those duplicates. Now, the interesting thing here is we now start to touch on entity resolution, and my argument of entity resolution is almost, you're going to have some kind of a definition, and this is going to be driven by your business rules, but you're going to have some kind of a definition that defines what you think should be one entity and how they should be grouped together. And let's pick a food example here. So a food example here, and again let's stick with almonds as an example. We might argue that actually we want to say that anything to do with like a raw type almond, so we might say that ground almonds, flaked almonds, almond, flour, etc., you know what, almond milk, all of those all belong to a group, and that group, that entity, we're going to call almonds, and maybe we've got some kind of hierarchy. We might say, no, our entity resolution actually is going to be the same as our deduplicating of the data, and that's going to be, for example, almond and almonds. That's one entity, we treat it thus, and actually this blog post goes off and deals with that for us. We might say, for example, we want to derive different groups. So almond milk, maybe we want to have a group called milks. So how do we do that? Maybe we go one up and go, well actually, we're not focusing on ingredients when it comes to entities. Actually what we're focusing on is the actual recipes. So maybe we've got lots of recipes, and the recipes have got different names, but actually if we go in and have a look at what are the ingredients that make up those recipes, and if it turns out that whatever the rule is, say 100% overlap to, say, within 90%, again to pick some arbitrary values based on our business rules, we may say, well actually the entity that we're trying to detect here are the recipes, and we're trying to say what two recipes are probably the same recipe but they've got a different name. But when we go away and have a look at the ingredients, then that's how we're going to map them. So there's going to be potentially a bunch of different things that we would define for the entities. So one thing I'm going to touch on in this post, because I know a couple of people are tuning in because they're sort of looking at entity resolution problems and what they might do. One thing I wanted to mention about this specific blog post is it does use an approach that I've had a play with when I'm trying to look at ways of doing entity resolution on people, for example, or a person, organisation, what you want to call it. So let's just I'll quickly flag that example here, just so you get a feel for what's going on. So this is a great example, this data model. So probably need a bit of abstract thinking here to get the idea of what's going on. But one approach you might use, and this may be useful to you, is if you go where I've got ingredient here, let's say ingredient actually is, say, a person, and we've got a unique identifier for that person. And what we can do is we can have a look at, say, a person, and let's say that person has a bunch of information associated with them. So they've got a name, they've got perhaps an email address, they've got a sort of a land address, the home address, where do they live. Maybe they've got a phone number, maybe they've got a number of other bits of information that describe them. And one of the approaches that I've used, and this is effectively the approach that is used in this blog post, is what happens if we've got another person and we want to try and figure out these two persons are, could they potentially be the same person? And the approach that I've used for this is going, well, we'll take this person and we're going to assign like some kind of identity or a pointer to them. So let's say we're going to give them an ID of 1, and we run a node of that, or pull them away, something like that. And then what we can do is we can go, well, okay, let's take that name. We're going to tokenize that name. So let's say we've got somebody called, just trying to think of a, I'm just picking a random name here. So let's say Mary Stewart as an example. So maybe in some places when a data's been ingested, that name's been brought in as Mary Stewart. Maybe in some situations that data's been ingested and it's come in as a Stewart Mary. So maybe you've got somebody called Stewart with the surname Mary. That could happen. Maybe actually there's a middle name associated, so Mary Lee Stewart as an example. So one thing I might do is I might go away and I'll tokenize that name. So by taking that name and tokenizing it, I don't care anymore about the order of what those names come in. So I can now start going through all of my entity, sort of all of my person nodes I've got in my database, and I can connect them all. So if they've got a component name of, text name of Mary, we connect them together. If they've got a component name of Stuart, we connect them together, and so forth. So you've got that element there. Another thing we can do, same approach, we can go away and connect up if they've got a common email address, and then maybe there's things we can do where we can clean up the email address if there's any sort of weird characters or things going on. So we can connect them up with the email address. We can connect up a home address as well. And again, maybe we want to tokenize that address, so we split out things like a postcode or a state or a county and so forth. So we keep splitting out, tokenizing information, and we're joining things together. And the idea by doing this is we're creating some graph structures, and then with this, and again sort of cut down version going on this post, with this we can start to go, well, okay, we're putting structures in, so now we can start to sort of enrich the graph with these additional structures, and this now allows us to run some graph algorithms across this data set. And again, you're going to have to think about some rules, so you have to think about how you're going to weight different things. So for example, you wouldn't want to get a situation where you're putting too much weight emphasis on names where, if somebody's got 3 name components, they've got a first name, a middle name and surname, and then maybe 1 or 2 other things match. You don't be putting too much weighting on the name, because then you may get some false things. But again, this is all about rules and thinking about the weightings on that. But effectively you can do something like this, and this is a similar approach in this post, and this is a way that you can do entity resolution, and it works quite nicely. So that might be something to go away and have a look at. So this is effectively what went on the post. In this example here, what we did was we had this idea of, actually let me just quickly show you the data model. That's probably quicker like that. So if I do, let's get rid of that and do. So just quickly show you what's going on. So effectively the bits that we are interested in for now are recipe, ingredient and ingredient name. So you think about, so we've got a number of recipes, so recipes contain ingredient, so we've got a list of ingredients here, and this ingredient could be, as we talked about before, it could be flaked almonds, almond flakes, and so on. So we've got all the ingredient names, and then what we've done, so again we were talking about these approaches about how many deduplicate data, or this may be a valid approach for your entity resolution, is we've taken that ingredient and tokenized it. So effectively we've turned flaked almond, almond flakes, so forth, we split them out. So here, if this is almond flakes, you'd have 1 for almond and 1 for flakes. And the additional thing I've done here, and again talking about what my business rules might be, is, and again I write these up in the blog post, I talk about, well actually I want to get rid of plurals, I want to, and again different types of plurals, so something might end in S, something might end up in, something might end with Y versus IES, and so forth, all the different things. I don't care about tense either, so again almond flakes, flaked almonds, we're dealing with a past tense in the latter example, so what do we do to get rid of that? So these are all of these sort of, these rules I've put around cleaning that data. I've made rules about things that sound similar, so I use the APOC library for those. And I do things around getting rid of stop words, so I get rid of things like with, the, and, etc. and short words. So these things, and I talk a little bit about the rationale of the blog post. So I don't want to go into a huge amount of detail about going there, but you start to get a flavour of what's going on. So that may be enough for what you're looking at if you're looking at entity resolution. Now for me, I'm still pondering what do I think about with regards to entity resolution with this data. So there is a number of things I'm really keen to try out. So the things that I'm really keen to try out will be around, can I do groupings? So for example, can I group together tomatoes? Can I group together cherries? Another thing as well that I'm really interested, again trying to use the structure of the graph, can I look at something like a cherry tomato, and how do I know a cherry tomato? Is a cherry tomato a cherry, or is it a tomato? What can I do? How can I leverage the data that I've got in my graph to be able to figure out what is a cherry tomato, or a beef tomato? Is a beef tomato beef or a tomato? And there's going to be many examples like this. Almond milk, is almond milk an almond, or is it a milk? Again, that one's probably going to have a heady discussion, and that's probably not something that's probably going to be more of a philosophical debate rather than what the data is. But you get the idea. So is entity resolution around trying to figure out whether a cherry tomato is a cherry or a tomato? Is it going to be trying to figure out a grouping section? Or as we touched on earlier, is it going to be something around trying to resolve recipes? Because this is quite a big data. I think there's something like 120 recipes in here, and there's probably going to be a lot of repetition of recipes. So how are we going to do that? And just touching on that, I don't have ingredient quantities here, so we might decide to keep this simple and say recipes with the same ingredients, because I could very sort of quickly flag an example of a latte, a cappuccino, a flat white. All of them contain coffee and milk, but obviously the big driver behind that is going to be the proportion of the milk, how do you process the milk and so forth. So for the purposes of simplicity, certainly at this point, I would probably say no, they're all the same recipe, so how would we resolve those then? So there's a lot of fun stuff to do here. I think this is a great data set. I well recommend if you get the chance, go away, get a copy of this and have a play with it, because I think it's absolutely fascinating what you can do. And it's real data. This is real data that people have uploaded, and I think you can do some really fun stuff with this. Okay, so, excuse me. So talked a little bit about the kind of things I'm looking at. So let's go straight in. And one of the things I played with that first jumped into my mind was, how would you go about saying, if something was a cherry tomato or a tomato? And there's probably lots of ways of doing this. But one thought I had when I was thinking about this was, well, okay, maybe what we can do here is there must be some kind of intermediary ingredient between, say, a cherry tomato that will basically tell you. So there must be some kind of way or some kind of category when you look at it and you say, well, a cherry tomato is probably put in the same recipes as, say, a tomato, or if we're assuming it's a tomato, or the cherries, if we're assuming it's a cherry. So there's probably some kind of relationship it's going to have with some other ingredients that's going to, that's going to basically tell us whether it's going to be a cherry or tomato. And if we go back to what we've done here, just as an example, so this is something that I thought about, is let's say we've got our cherry tomato here. Actually, let's bring up cherry tomato. That's probably a lot easier. So let's do was it up? No, it's lowercase, isn't it? Cherry tomato, and we want the ingredient name. And I want to get those components, so the bits that I tokenized for cherry tomato. let's just call it C, and we're going to return all of that. Okay, so we've got cherry tomato, and we have these two components that we've split off and cleaned up and done all of that good stuff. And just as an example, if I double click on tomato, we'll see all the other ingredients that have been linked to that tokenized tomato. So you can see here we've got tomatoes, chopped tomato. You can see all the plurals and things. So one activity I haven't done yet, which I will go away and do at some point, is we've done some deduping. So what I want to do is now get rid of some of these and clean up the data set. Haven't done that just yet, but that's something I will put on my to-do list. And I've just got to decide how I want to represent that. So I haven't got around to that just yet. But you've got all the various things with tomatoes linking to tomato. Let me just clear those. There we go. So we've got our two components. So we've got cherry tomato, and it's either a tomato, or if I double click on cherry, we'll probably get other things like glacy cherry, sour cherry, all the cherries. And we've got that question. So is a cherry tomato a cherry or a tomato? And obviously this isn't going to work for everything, but it's a fun problem to think about. So I was sitting in thinking, well, actually, can we use an intermediary ingredient? So you think about cherry tomato is going to be in some recipes, and there's going to be other ingredients that also go in with cherry tomatoes, but presumably that other ingredient is also going to be in other recipes, which is going to be with something that refers to either cherry or tomato. And that's going to, and if we can use that sort of that pivot point, that sort of linking ingredient, so effectively using that graph structure, hopefully that's going to give us some information about whether a cherry tomato is a cherry or a tomato. So, and this is a sort of very blunt instrument I've used here. I'm going to show you the query that I came up with. But basically it's going, if whichever one of these has the highest number of links, then that's probably what that item is. So let me copy and paste that query. And let's just talk through what's going on here. So what I'm doing here is matching our cherry tomato, so this will be whatever ingredient I'm looking to match. And then what I say here is I want to get the components of cherry tomato, so we know there's going to be a node called cherry and a node called tomato. And then with those, I want to get the paths for where that component, features an ingredient, which then features in a recipe, which then features another ingredient, bear with me, which then contains that ingredient to a recipe, which contains that ingredient I that we're interested in. So basically saying, well, our start point's going to be the ingredient components that we've pulled back, our end point's going to be the actual ingredient, and then what we're saying is we'll count the number of paths where each of those components feature in a recipe, and we're using this item here, this ingredient here, and that's our pivot point. So let me give you an example. So let's say we're thinking about a salad, and you think about a salad, and a salad's going to have a cherry tomato, it's probably going to have cucumber, it's going to have lettuce, and then you think about another recipe for a salad, and then that recipe for salad is probably also going to have cucumber and salad, and maybe it's got a beef tomato in there, maybe it's just got tomatoes or whatever we've defined. So effectively what I'm trying to do here is use that other ingredient as a pivot point to link through. So let's have a look here. So you can see I bring these back. I don't want to, what am I doing here? So I don't want to be using the same ingredient point back. So I don't care about, I don't ever want to be using cherry tomato as part of the ingredient. Okay, and then I'm going to turn these back, and I return the distinct name. I want to return back the component name, and I want to know how many paths that featured in. So let's have a go. So if I put in cherry tomato and it goes where I need to look. So the only problem with this is quite an expensive query. So something I want to do is go away and have a look at how I make this faster. But just as an example there, so you can see we've done this, and again we need to do some thinking around what kind of ratios, how we're going to weight this, and so forth and so forth. And example here, we've got sort of cherry tomatoes, got 27,000 hits. So I'm going to be really keen at some point to go in and figure out what were those recipes that have cherry tomatoes and cherries. So that's going to be a fun one. But the vast majority, so what, 11 times more frequently appearing, is that tomato and cherry tomato belong together. So that's really fun. So that's something we can use. This is really expensive, so I'm just going to pick a few. So this does break occasionally, so I think when I put in white chocolate, it comes back as white. So let's have a go at that. So white. I think this is that there are a few where it doesn't quite work out. So you get like chocolate and white, and apparently white, it's kind of like a 50-50. So it doesn't work for everything, but it's an idea. So, you know, potentially if we were thinking about sort of the number of processes that we wanted to apply, if we wanted to think about the number of the kind of processes or processing we wanted to apply to our data, this could be one of those. And what we can, you know, maybe we figure out what is the threshold we want to apply to this, and we might say, well, actually, you know, anything that is like, I don't know, at least, you know, 20-80 split or something like that, then we're going to go, yep, that's going to help our grouping. And if it's fuzzing that up, again, that's a very arbitrary way of doing that, but you start to get an idea. And I'm going to, for entertainment, I'll pick another one that was quite fun. I'm just trying to think of red curry paste. That's a... So you've got a few of these, so you get the idea. So what's a red curry paste? Is it curry, is it red, or is it a paste? So there is a lot of interesting things around what you can do that. Oh, tiger prawn, that would be fun. There you go. Is a tiger prawn a tiger or a prawn? Which then sort of, that's probably going to be tiger bread or something in there as well, would be the other 44. But you get the idea. So this is a great example of how we're using graph structures. So effectively we've built a relationship between our ingredients and the recipes, and effectively what we can now do is we're using graph structures to be able to tell us what group something probably lives in. So that's great fun. So this was kind of the stopping point where I left this when I was investigating some thinking around this. And something I'm very keen to do is to go away, can I make this more performant? There's some tricks I can use to do this better. So the next thing I was really keen to have a look at is, can we do something like weakly connected components? So can we use something like that to be able to do something useful for us with the realm of entity resolution? So what I want to do is quickly have a look at the docs on that. So you've got the graph data science docs. So I'm now going to go in and just have a quick understanding of what it does, because I'm aware of using weakly connected components to try and find potential groupings of data, but I'm not yet quite sure how that's going to apply to the data set that I've got here. So I'm going to go away, I'm going to be looking at the documentation and figuring out what is going to, you know, how can we apply this and see what happens. The one thing I really love about the graph data science algorithms, actually I need to check if I've installed them on my database. The thing that's really great about them is the layout. Oh, I'll need to add that, so I'm going to add that now. The thing that's really great about them is because the syntax is the same, it's really easy to sort of switch through and rerun them and change the parameters and so forth. So it's really good for that. So whilst that's doing it, oh, there we go, brilliant. It's restarting the database. So let's have a quick look at weakly connected components. And again, if you've got any suggestions or something you want me to have a look at, do let me know and we shall investigate those. So weakly connected, that's a community detection. So let's go have a look. Weakly connected components. Okay, let's have a look. And maybe we can have a go, actually for a bit of fun, maybe we can have a go at treating recipes as a thing we want to deduplicate, find the entity resolution of. So we'll have a look at that in a second. So let's have a quick peek at weakly connected components. Is this something that's going to be helpful for us? So I always like to have a look at an example and what the output happens, what comes out of the output. Ah yes, the common ingredients. So that's a really good point, Nathan. So it's that if actually I did have a list of let's do a quick query. So there are a lot of very common ingredients. So I think olive oil was the #1 common ingredient. Ah, could we check them for between a centrality? Yeah, so that's an interesting one because we can let's do that in a second, because the interesting thing I guess with things like flour or salt, or certainly salt and oil, they probably feature together in a huge number of recipes. So you're probably going to have something like, I'm sort of guessing here, but what, maybe 70-80% of your recipes are probably going to have oil and salt together. So if you were going to do any kind of sort of analysis of like the groupings together, you probably want to exclude those. I'd probably be excluding those ingredients because they're going to have a skew. So okay, let's bring that up quickly. So this is back. So what did I want to do for common ingredients? Have I already written something up? Okay, so let's do. Right, that's going to be match. Ingredient. Oh, what direction was the recipe? Oh, why is my linter not working? Alright, we can just quickly, just going to remind myself what this data model looks like. Actually, I can reuse the query that I wrote whilst this is connecting. Contains ingredient, that's what we want. Let's see if the database is back up. Oh dear. Let's remove this. I think I need to get a new version of the database, so I'm just going to quickly upgrade this because that's probably what's going on here. I suspect why it's crashing here is because the database version is a bit... Yeah, so there's been a more recent release of the Graph Data Science Library, and I suspect it may not work with 3.5.15. Something for me to check, but I am going to guess that's why it is not happy. Okay, this is gripping. But yes, so yes, the ingredients one is an interesting one, because one thing I definitely wouldn't want to do is do that trick on olive oil. Like, do I want to find out whether olive oil is an olive or an oil? I mean, the query that I put in there is quite an expensive query, and I would probably need very, very large amounts of RAM to run that. So it's probably one to miss. But I guess maybe we do some kind of pre-filtering on that. So we'll probably check to see, well, if it's not in the, I don't know, top 10 most popular, or we do some kind of ratio between the number of sort of recipes that ingredients involved, and then accordingly we avoid running that query on that. So, which actually, it's an interesting thought around that is, do you then class that ingredient, the popular ones, as the top the sort of top one? Anyway, okay, so let's add our Graph Data Science plugin now, because we'll be using that shortly. Okay, and hopefully the database will be happy now. Oh dear. Okay, so what we'll do, I will investigate what's going on here later. I guess we will probably see what we can do without... Actually, let me try manually installing the plugin. Let's just quickly have a look at what the error messages say. So will it start without the plugin? Maybe I need to get an older version. So let's have a quick look. I'm pleased to hear it's useful. So I suspect the thing that's upset it is the Graph Data Science plugin, and I'm not sure why. So first thing I'm going to do, actually let's do this together. I'm doing this in a separate screen, but let's do it together. So what I want to do is have a look just at any information on the plugin to see is there something about the release notes. So should I be using this on a specific version of the database? So just going to have a quick look here, Graph Data Science. So let's have a look at the release notes. Oh, there we go. That would be why it's not working. So I'm trying to use an older version of the database, so that's okay. What I'm going to do is I'm going to, look, that would serve me right for not having a look. So that's fine. So what I'm going to do is I'm just going to get an older version of the plugin. So I want to get 1.1, so I'm just going to double check the release notes to make sure that, yep, there we go, that's fine. So we're going to grab a copy of that, and just going to download it. And I'm going to... Right, so we know this works. I'm just going to stop this, stop the database, and I'm just going to pop it into the plugins folder. So this is if you are manually adding some plugins, and so I guess for those of you who are using Neo4j desktop and you want to and you want to be able to use an older version. So I've got the folder opened here. So what I'm going to do is just go to my downloads and grab a copy of the jar. I'm just going to click and drag it into here. Okay, so I may need to tell, I don't know what's in the config, so I may need to tell the database that we've got GDS in there. Let me have a quick look. Oh, we're in there, excellent. So I don't need to make any changes to there. So for those of you, you do need to let the database know if you're using plugins that you've got them in there. So in this example here, you got the setting DBMS security procedures unrestricted. So here, for example, gds.star says allow all of the graph data science procedures and functions to run. And obviously you can see I've got one here for APOC as well. Okay, so we've got that in. So with a bit of luck, we're all going to be set and working now. Oh, ignore these guys. I was just playing with the new feature of desktop, I suspect, at that time. But it's just cool. Maybe at some point we'll have a go at building a browser guide for the BBC food dataset. That might be a fun project to work with. Oh, I forgot to add. Oh no, it should be in there. It should already be in there. We just ignore that bit because we did it manually. All right, let's just get the database going. But yes, I think it was when last time I did this. I think it was olive oil was like the #1 ingredient, which is good because olive oil is very good for you. There we go. All right, we are back in business. So let's run this trusty query, and this is going to give us the most common ingredients. There we go. Olive oil, #1. Olive oil and butter. It's like sort of like ingredients after my own heart there. I think that's fantastic. So we get an interesting question again, sort of coming back to what Nathan pointed out, is we're going to have these really big ingredients. Given that how many recipes we've got in here, let's do a quick so we've got something like, so we've got 11, let's call it 11,500. So we've got 11.5 recipes in here, of which sort of olive oil makes up a quarter. So that's a popular ingredient. So we wouldn't, when we're thinking about how we're doing these centrality algorithms, we need to be really careful about things like this, because you may end up like massive grouping of those just because of it's so well connected into networks. So let's come back to what Nathan was saying there. So, okay, so let's have a look at weakly connected components. And the really cool thing, what I really like when we're using the graph data science algorithms, is the thing we can do is we've got sort of different ways of how we can tell the algorithm what we want, or what data we want it to run on. And so you've got one, so the super fast, I've optimized my graph for production, etc, 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 and you've got like this super fast loader where you basically ensure that your data is in this sort of one-to-one mapping of what you'd run the algorithm on. And there's ways, obviously, within reason, so there's you probably can sort of manage multiple models in your data, but effectively you do sort of one-to-one where you tell it, right, I want these relationships and these node types, and it will just go off and like great speed just go off and pull that in. So that's great. For example here, where we're doing this data exploration, I don't necessarily want to bring everything in and coming back. Oh yes, I'll have a look at that blog post, Nathan. Good shout there. Let me just quickly pop that in here as well. Keep track of these. Ooh. So we've got these. Oh, excuse me. So what you can do is you can effectively say another approach is you can use the cipher loader, where you go, well, actually, what I'm going to do is I'm going to specify a specific cipher query, and I'm going to push the information back. So just as an example, if we're looking at the weakly connected components, let's see if we've got an example of the cipher loader in here. So, oh. That's okay, I'll do an example here, but effectively what you can do is you effectively write your cipher query to say, to dictate what data you want to bring up. So for example, if we were doing something like node similarity, we're going to run the node similarity algorithm, and we didn't want to include basically our top contenders in this list. If we want to say, you know what, we want to ignore olive oil and butter and garlic. So when I've gone through and like retagged the duplicates in this data set, the interesting is obviously garlic and garlic clove you'd expect to compress down. But you probably would, like for certain algorithms that you're going to run, you're probably going to say, well, actually, I don't want to involve olive oil because olive oil tells me nothing. Like there's a 25% chance that olive oil is going to feature in one of my recipes. So why do I want to? It's not even, it's less than that. It's like probably like 30%. It's got a 30% likelihood of olive oil appearing in one of my recipes. So I don't want to include that. So what you can do is you can basically go away and say, well, I'm going to write my cipher query. I'm going to say what I'm providing, and effectively what you do is you provide a set of node IDs, and the node IDs will either say these are the nodes I want you to consider when running this graph algorithm, and you also provide the node IDs to say, for the purposes of relationship, saying, well, this node ID is the start point, so this node, whatever the node ID is, assume that's one end of the relationship, and then this other node ID, assume that's going to be the sort of the exit point of the relationship. So effectively, you submit a set. You're effectively doing a cipher query to submit your node IDs. And so what we can do is we could probably write a query saying, match I ingredient where not ingredient name equals, and then we put in, like we say, we don't want olive oil, we don't want butter, we don't want garlic clove, and so forth. So you have that flexibility, and almost to some extent we'd probably get rid of anything called oil, and this is where we're using our domain knowledge to say, well, actually pretty much anything can have oil in it, so let's just not bother doing that. And I guess that's probably something for us to think about. What are the things that we'd want to just completely exclude from any kind of query? And this is going to come down to our sort of knowledge of the domain and so forth. Okay, so let's have a look. So let's go back and have a look at this. So what we're saying here. Bridget, Alice is linked to Charles, Mark is linked to Doug. So how would this be useful for us? Let's have a think. So this would Doug, Mark and Michael, Alice, Bridget. Okay, right, so this would probably be helpful for us if we were looking at recipes. So which recipes might be connected to each other, and that's going to do it over the ingredients. So I think that would be a good application. So the question around this would be, how do we how do we structure this in a certain way? So we're potentially going to have to add some links. We're going to have to link the data in some way. So this is so this expects a monopartite graph. So what that means is it wants to treat it basically wants a node of one type, and I use the node of one type loosely because remember how I said we can use the cipher query to effectively say, hey, these are all the nodes we're interested in. But the point here is that we're not differentiating between two different nodes. We're effectively going to clump a bunch of nodes and say these are all the same thing. So let's have a think about what this would look like. So if we remind ourselves, let me bring back this and let's do. So where I think this would be useful, let's stretch this out a little bit. So again, so this is not going to be using all that lovely good work that we've done to find ingredient duplicates. So okay, that's fine. We just rerun this again later when we have done that cleanup. But effectively, where I'm thinking for the weakly connected components is we probably want to create a relationship between recipe, and we're going to do that via ingredient. So let me bring up arrows so I can do an example of what I'm thinking here. So I'm just quickly clearing out what I did. I'm working with something in arrows at the moment, so I'm just going to get rid of that. And okay, so let's have a quick look. So where I'm thinking what we can do. So if we do an example here, so let's say we've got a recipe, and let's say this recipe is going to be for I don't know, Greek salad. And this recipe contains an ingredient. Stick with tomatoes. I love tomatoes. Name, cherry tomato. And let's say we've got another recipe. And let's say this is going to be, let's go for a bit random. There's this aubergine stew recipe that I make that uses cherry tomato. So let's go with that. Or an eggplant, for those of you who are curious as to what exactly an aubergine is. So an aubergine also contains cherry tomato. So what I'm thinking, and this is going to be crazy messy and potentially quite a slow query, but what we potentially want to do is want to say, well, if these two recipes have got a common ingredient, then what we want to do is we want to say, actually we'll use the loader for this. So what we want to say is to create this, certainly when we're loading the data up into for the graph data science, sort of like the in-memory graph, so they can go off and do the processing, we want to say has common ingredient or something. Something like that. So we're effectively doing something like this. So anything's got that, and then so by doing this, then what we can do is we can do, let me just pop a couple of nodes in to make it a bit easier to see what's going on. Oops. So what we're effectively saying is, if they've got a common ingredient, then we want to recognise that by saying there's this link between the two of them, and then we can, and then this is effectively, we're going to have a graph consisting of this. This is going to be our in-memory graph for the purposes of the algorithm, and then that will go away, and then hopefully we should get some interesting components. Now, let's see what happens. So let's do both. So we'll do both with where we don't exclude the common ingredients, and let's do one where we do include the common ingredients, and let's just see what happens. I mean, you know, it's always good to experiment and see what's going on. So let's give that a go. So let me just quickly confirm what the documentation says. So the documentation, do we need to provide any default values? Do we need, I don't, because they've got weights here, do we need to provide a weight? I think we can do an unweighted weakly connected components. So the interesting thing here, maybe for the weights, we'll have a little think around that. The weights could well be if, you know, for the number of common ingredients that two recipes have, we keep incrementing that, because what's going to happen at the moment, we're going to have lots of potentially relationships. So if we look at an example of, say, for argument's sake, let's say a Greek salad and an Italian salad and a French salad, they're probably all going to contain tomatoes, they're probably all going to contain cucumber, maybe they'll contain sort of onion or something like that, or they'll contain olive oil. So there's going to be a bunch of things, and you can easily see that there are going to be multiple relationships between, say, an Italian salad and a Greek salad and a French salad. So you're going to have multiple links. So let's see what happens, and then we can have a rethink about how we're going to put those weights onto those relationships, and then we can compare and contrast and see what happens. All the good fun of data exploration. So what do we do? So this is in stats mode. That tells us what's connected. We've got anonymous graph. We're not going to do an anonymous graph because we're probably going to need the data over again. Estimate, that tells us how much memory we need. Create it, so we've got locally. So what I want to do is I want to stream. So I'm going to do a stream here. And the reason why I want to do a stream here is I want to get these component IDs out, and then what I'm going to do is I'm going to create nodes, and I'm going to connect the names that come back, and I'm going to connect those to the new nodes that create these entity nodes, or we can call them WCC nodes or something like that. We'll pick something sensible to call them. So we can connect them back to that, and then that gives us a nice easy way of being able to explore what communities have come in. So what I'm going to do is I'm going to copy this, and I'm going to pop in a second so that we can have a look, and we just copy the syntax that we've got for there. And I'm also going to load a graph for this, so I'm just going to check. Right, so let's load in the graph for this first. So we're going to do gds.graph.create cipher, because we're using the cipher loader. Let's call this WCC, because weekly connected components, and put this on a new line. Oops, what did I do? There we go. And let's say match. So we want to return the recipes. So we're going to return the recipe node. So this is the node IDs that we need to do. So we provide two things to the memory loader. So the first thing we provide is we're telling it what nodes it's going to do, and then the next query we're telling it what relationships, so how are those nodes connected. So the first thing we're going to do are the nodes, and we want to do all the recipes because we're trying to do the weakly connected components over the recipes. And let's do recipe. Okay, and then so the way we tell it what nodes we want is we tell the algorithm the internal IDs of those nodes. So return ID R, whoops, as ID. So it's always got to be as ID, so it knows that you're giving it the nodes. And then let's provide the relationship. So we do a second cipher query for that. And this is where we're going to do that thing where we're going to go back to the arrows diagram. So what we're going to do, so this is the first part of our query, is going to be finding this path here. And then what we're going to do is we're going to return the ID for this node and the ID for this node. So let's do that. So we're going to do match part1 recipe and then has contains ingredient. And then we've got our ingredient. R2 recipe. Oopsie daisy, spell that correctly. So that's effectively, we're now using, so specifying the graph pattern, so we're saying how those two are going to be connected. And then I'm going to return ID R1 as source. So here we return the IDs and we just call the ID source and target. So here we're going to be it's going to be undirected weakly connected components. I'm not too worried about this. Something to bear in mind, and again, oh no, let's correct for that. So something to bear in mind is we may have a boomerang situation happening here, where it goes through, it finds R1 and then it connects to R2 and then it's going to boomerang back again, so it goes R2 goes to R1. So I'm just going to put in a where statement to just stop it from doing that double pass. So let me just finish off this query and then we're going to add that bit in. So as source and then ID R2 as target, and let's just quickly add in that bit. We're just going to say where ID R1 is greater than ID R2. Okay, so we're just going to stop that. So I'm just using the internal IDs as a comparator, just so that we stop it doing that double path. Yep, good point, Tomaso. So we can have a look at that. So we can also look at the number of common ingredients as the weight. So we'll do that in a second. So let's do this one first and then we can have a play with using the common ingredients. So that's something we touched on before. So we were thinking about how do we do the weighting. So we put the weighting on the common ingredient. So we'll put that on the to-do list. And let's have a look at this. So hopefully, okay, it will tell us if there's an error in the cipher query. So let's just pop this. Let's run this. It might take a long time. Maybe we should have done a smaller data set. Yeah, no, absolutely, Tomaso. This is something we talked about. So we probably, at the moment, we're going to have multiple relationships between two recipes based on that. So okay, if it balks at trying to load the graph, then what we'll do is let's have a think about how we can count the number of common ingredients and then put that relationship between them. So actually what we could do, do we need to specify the property, or can we, because the only thing I'm thinking about with the weights is you specify a property that has the weights. Can we actually specify it in the query as a weight? Now let's have a quick look at creating a graph, because that's the only thing. Because if we need to, by all means, absolutely we should supply the weighting. The only thing I'm wondering about is if we need to provide the weighting, then we'll actually need to physically create that relationship so that we can attach a property to it. So let me just have a quick look if we can we do that in the projection? Can we put in, aha, okay, let me have a quick peek. Or by all means you can, ping me an example of the syntax and we'll chuck it in. I see. Okay. So return the source, return the oh, I see, and then we can put it to, yes, no, nice one, that is brilliant, thank you, Tomaso. Let's bring, okay, oh, it's still alive though, so that's good. Alright, let's do that, so let's drop this. Is it drop? Yes, drop. Let's get rid of this. Okay, so let's rewrite that query. And we said what we can do. So let's do route to the target and so I'm just trying to think about the cipher query here, because at the moment we're not. Because at the moment this is going to go through all the paths, and what we probably want to do is, do we need to distinct this? I'm just trying to think, or will it be smart enough? Let's do ingredient for there. Call it CI, common ingredients, not CCI, common ingredients. Okay, so I think at the moment so the only thing I'm worried about at the moment with the query, so what we can do is, let me just grab a copy of this. The only thing that I'm worried about at the moment, so I think what we need to do is we need to do some kind of a with or a collect before we put it out, because I think what's going to happen is it's going to do each line as a separate count. So what we can do is let's just see what happens, and let's limit this to a few. Limit 5. Let's see what happens, because I suspect it's going to do 1 1 1 1 1, and what we need to do is we may need to do like a with, so that we collect all of the numbers and then push through the ID and the thing. So let's just, oh my goodness, what monster have I created of a query? So yeah, so what I'm worried about here, so I'm going to cheat slightly and pick, no, I don't want to pick an ingredient. So the only thing that I'm concerned about the current query as it is with this is it's going to treat each one as an individual line. Yeah, so I've got an example for the Louvain one where we don't worry about the IDs. But here I'm just trying to think. So what I'm worried about what's going on here, and I'm a bit surprised this query is taking such a long time to run. But what's happening here is I think this is going to treat each one as one line. So it's going to be like, I don't know, cappuccino contains milk, contains ingredient, coffee, and then it's going to do count 1, then cappuccino contains ingredient, sugar contains ingredient, I've got latte, anyway, 2 coffees, 1. So I think what we might need to do, some kind of a collecting type thing with a with. So if I'm going to stop this, I don't know why it's taking such a long time, because I have limited it to 5, but what I think we probably want to do here is something like with R1, R2, count I as CI. Then I think hang on, let's see what happens. Yeah, actually, that's a good point. That's a good point, Nathan, because we can split it out. Let's have a quick peek. Loader documentation. native projection. Well, let's go crazy. I don't know why this query is taking. Let's go back to the one we created and run it and see what happens. Worst case scenario, I get showered with error messages. Not bad. Not a bad worst case scenario. Right, so let's do this, and so let's put in art. So count irons. Okay, so this was reasonably quick at loading. So let's do that, and then we're gonna go at running this. Whilst that's churning away, let's copy this one, and we're going to call this we connect components, and we want to specify the property name. So let's quickly remind ourselves of what that looked like. Weekly connected components. And oh, did we have the example of weight in the one I just copied? Let's have a look. No properties to project during anonymous graph creation. We're not doing that, are we? Relationship weight property. The relationship property that contains the weight. Okay, so we want this one. So we're going to do this, and we called it CI. I assume that probably needs to be in quotes. Okay. So how long did it take last time to generate that graph? Ooh. A minute. Okay, so maybe we need to drop the property. We'll give it a couple of minutes, and if it's taking ages, then we'll go back to we created this one, and we can just run it and see what happens. Live life on the edge. It's all learning. Taking quite a while, and I guess that there are more interesting things to watch than my PC trying to load a graph. So I'm gonna kill this. Let's bring up the previous one. So we know that, let's just gonna make a copy of that so I don't forget. let's go back to this one, which we know loaded in about a minute. The thing that I'm really excited about, so whilst it takes a while to load up the data, I think weakly connected components is one of the fastest algorithms we've got in the library. So quite keen to see. It probably takes longer to load the data than it does to run the algorithm. It's all good fun. Well, if any of you are working on entity resolution problems and want to chat about them, let's whilst waiting for the graph to load, let's hear about what you're working on. If you're at liberty to discuss, of course, or if you want to discuss. If you don't want to, it's fine. Okay, excellent. Right, so let's have a look at this. So we're going to be ditching the, oh, where did I put a copy of this? There we go. So the component, okay, let's just run it. This should be relatively fast. So we're not specifying any parameters for now. Let's just see what happens. Oh, that was very fast. Okay, so, oh dear. Oh, don't tell me everything belongs to community 0. I think that's what's going to happen, isn't it? Oh. So let's do... I have a suspicious feeling that we have a lot of zeros, so what might be happening is we probably really need to get that weighting in there. Yeah. Okay, no, that's fine. That's fine. We like this. We can see what's happening. So what's probably happening, because everything's got the same weight, we're not making it easy for it to distinguish. So let's have a think about how we can add that weight. So I think we're going to have to persevere with the slow graph. So I'm just going to have a quick peek at the documentation for native graphs. Is there something we can do? Is there some kind of native projection? Is there something we can do to no. Yeah, and I don't really want to put in the new relationship, because that's going to be a huge Cartesian sort of blowout. Because you think about, we've got something like 11,500 recipes, and we're going to do for each one, we're going to match through and count how many common ingredients. That's quite an expensive, it's quite an expensive query. Although admittedly when it was loading the graph it was doing that. But let's see if we can, let's have another go. Let's have another crack at loading the graph. So we're going to drop this one. And what can we do to speed this up? No, I don't so much. Yeah, let's go for broke. Let's load this big one up. It's probably going to take a while, unfortunately, but that's okay. That's okay. Then we can have a think about what we do in the future, and maybe it's just worth putting those connections in the future. So, okay, so we're going to add that property of count I as CI, and that's just going to, actually we should probably just do a quick, let's just check, just doubly make sure this query is going to behave how we're expecting it to behave. So I'm going to cheat a little bit slightly, and I'm going to say I'm going to just try and cut down the amount of data we're bringing in, just so we can see this is working. So let's do for our recipe where r.name contains salad, and then match r contains ingredient, return id r, id2 is target, r. Okay, let's see if this does what we hoped it did, and hopefully this should be a much smaller data set. Oops. Oh yes, I forgot to return something. Oh gosh, that's quite a lot of salads there. So let's make this query a bit nicer. I'm going to further restrict this to like limit 5. Oh, I forgot my width limit 5. There we go. Okay, right. So let's see what's happening. Okay, so it's doing what we expect it to do. So you can see we've got the source, we've got the target, and we're getting the number of common ingredients. Okay, so we know roughly what's going to happen. We've got an idea of what the graph load is going to do. So we are going to run this and be patient, and hopefully it won't take too long. Right, okay. This might take a while. That's all good though. And we can just update our streaming query. So whilst we're waiting for the graph to load, we can be prepared. And we said it was, what did we? What did we say that it was called? Relationship weight property, that was the one. That's what we want. It's going to be called, and I think we need to put it in quotes, don't we? We can double check that documentation. CI. And then what we want to do is we're going to yield, and I'm going to put all my eggs in one basket and assume that this is going to run fine. So we're going to yield the node ID and component ID, and then let's create. So we're going to do create Actually merge, no we want to merge. Let's do, let's call it, I was going to call it week, for want of a better name. Merge week, and ID is going to be component ID. And then we want to with node ID with WCC create WCC in community and we want to convert let's convert back it gds.util as node and WCC. Okay, so we're going to do, we're then going to attach our, this is going to be our recipe node. We're going to reattach our recipe nodes to this new entity group.